In this video, we're going to talk about inverse functions. I happen to love inverse functions. I think they're really nifty. And they seem very complicated, but they're really not. They have a simple idea that we just kind of keep exploiting over and over again. So I kind of altered the definition from the book to include really what's going on with an inverse function. So the inverse of a function is reversing the input and the output. That's the first sentence I wrote there. The inverse of a function is when a function has a reverse of the input and the output. So we use the notation f inverse of x, -1 notation. That's not a power of -1, which is why it's kind of next to the f to denote that it's not a power of -1. And what it means is that if f of a, if I have my original function and it paired up a with b, then the inverse is going to do the opposite. It's going to pair b with a. It literally is switching the input and the output. So visually what's happening, this little graph here, is that the domain of f takes a, right, a, and it maps it over to b. So this is what f of x does. But the inverse goes the opposite direction. It takes b and maps it to a. So the domain for the inverse is the opposite. So this is domain for f inverse. Oops, there's supposed to be a negative on there. Come on, let me fix it. Thank you. Whereas this is the range of f inverse. So it's the exact opposite of the function. I did make a mention that to note that -1 is not power, it's a notation. So don't treat it like a -1 exponent. So let's kind of explore this a little bit. Let's say f of 2 equals 4. So for the inverse then, f inverse of 4 equals 2. It's reversing. Okay, so let's look at domain and range then. If f of x equaling 2x has a domain of -1 to negative infinity to infinity and a range of 0 to infinity, what's the domain for f inverse and what's its range? Okay, well, the domain for f inverse is going to be the exact opposite. It is the range. So its domain is 0 to infinity and its range is -infinity to infinity. It's taking what's going on with f of x and switching it. So simple. Okay, so then let's look at a table. Let's find what f inverse of 70 is and then interpret what that means. So f of t is a table that shows the distance in miles that a car has traveled in t minutes. So f inverse of 70 is going to be the exact opposite. So I'm looking now at the output. So since the output of 70 right there, I'm looking at its output because the inverse does the switches them around, right? For the inverse, these are the inputs and these are the outputs. So it's switching them around. So that means its output is 90. So what that's saying is if we are going a distance of 70 miles, a distance of 70 miles will occur in 90 minutes, which is basically saying the same thing for f. It's just saying it in reverse. All right, let's look at another example. So let's say this time we have a graph and they're asking us to first find g of 3 and then find g inverse of 3. So two very different questions. So g of 3, that's just figuring out, oops, whoa, sorry, bumped the screen. That's just figuring out from here, going to 3 here, starting at 3, 2, 2, 2, 2. Okay, that has an output of 1. But that's different when we're looking at the inverse. The inverse is treating now the outputs as the inputs. So I'm going to 3 here on the y-axis. So this is the 3 I'm interested in. Boop, 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 boop. I don't know why I'm making this stupid noise. I just did it before. And that's then going to be at 5. So the inverse is doing the opposite. It's treating the outputs like the inputs. Okay, so let's say we want to find the inverse from a formula. There are some steps we're going to take to do that. Here are the steps. First, you're going to actually let f of x equal y. So we're going to take and actually make f of x a y. I find it's a little bit easier if you do it that way. Then you're going to switch x and y. So everywhere you see an x, you write a y, and everywhere you see a y, you write an x. You literally switch them. Such a sad x. I'm sorry, I'm trying to make it better. There we go. Then you're going to solve for y. After you switch them, you're then going to solve for y. And then your last step is to switch it back into inverse notation. Let y equal f inverse of x, or whatever function label we're using, if it's not f, g. All right, let's look at these steps in this example. Let's find the inverse of this equation. So first thing I'm going to do is I'm going to change f of x to be a y. Then I'm going to switch x and y. So this is going to be an x and this is going to be a y. Now I'm going to solve for y. So I'm going to add 5 to both sides. So that's x plus 5 equals 2y. Then I'm going to divide everything by 2. So I have, let me just write it over here, y equals x plus 5 over 2. So my final step, I'm going to rewrite this y as f inverse of x. And I'm done. I found the inverse. And what's kind of cool about, you can kind of see that it's actually inverting the process of the math. So in the original f of x here, we multiplied by 2. But down here in the inverse, we're dividing by 2. In the original, we're subtracting 5. But in the inverse, we're adding 5. And we're even inverting the order with which we did it. So if I were to plug something into f of x, I would first multiply by 2 and then subtract 5. But into the inverse, I would first add 5 and then divide by 2. Like that, the literal process is also inverting. So that's how you would find the inverse. Not too complicated. There are more complicated examples. Let's look at a little bit more complicated one. So first thing I want to do is I want to call this y. Myself a little space here. There we go. All right, and then I'm going to switch x and y. And now I'm going to solve for y. Do that, I'm going to need to cube both sides. I got to get rid of the cube root. So to get rid of it, I'm going to cube both sides of the equation. So that's going to be x cubed equals, so that becomes just y minus 4. I'm going to add 4 to both sides. So that's x cubed plus 4 equals y. Okay, so now I'm going to make this f inverse in here. I'm going to also reverse it while I'm doing that. I like it written with the f inverse on the left. So x cubed plus 4. So that's the inverse. And it makes sense. Where the original function f of x is taking a cube root, the inverse is doing the opposite. It's cubing. Where the original function is minusing 4, the inverse is doing the opposite. It's adding 4. All right. Now, the next video, we're going to talk about some interesting properties for inverses that kind of we should listen to kind of know, but I will save that for the next one.